Welcome to the video on MOSFET. So this is in the module 4 field effect transistors. So in the previous videos we have discussed what is meant by field effect transistor, how it works, and also we have studied about the mass capacitor. In mass capacitor we will based on the applied voltage to the device, it can operate in the accumulation or in the depletion region formation layer and inversion layer. So these three are the principal operating mode of the mass capacitor. Knowing or understanding the basics of the mass capacitor, we will study about the MOSFET, that is metal oxide semiconductor field effect transistor. So the transistor, we can say it as a four-terminal structure, but the fourth terminal, that is the body, will be normally considered as a reference point. So here we take the peak substrate. So P substrate in the sense the substrate is a lightly doped P-type semiconductor it forms the main body of the device. We normally use silicon or gallium arsenide for this purpose. Then for an N-channel MOSFET, they will be having two heavily doped N plus region which is separated by a distance of L. So the L is nothing but channel length and it will be normally in the range of 1 microamps, and W is nothing but the width of the substrate. So here, since there is a channel between the N region, it is called as an N channel transistor. Similarly, for an P channel, we will be having a N type substrate in which we will be having heavily doped P material. So there the channel is P type and hence it is called as a P channel MOSFET. Here the gate, which is normally a metal which can be nowadays is replaced by a polycrystalline material. So it, even though then it is called as metal oxide semiconductor field effect transistor. Otherwise, it is called as insulated gate field effect MOSFET or IG FET. IG stands for that gate is insulated from the device by means of the semiconductor material. So comparatively, this MOSFET will be having higher impedance, input impedance when compared to FET. So of all the devices we have studied like diode, transistor, JFET and MOSFET, the MOSFET will be having a very high input impedance. Also, the MOSFET will be having it will be having very less noise effect, and it is used in all the IC fabrications. And you can see that the recent CMOS is nothing but complementary metal oxide semiconductor is 1P and N combined together. So coming to the MOSFET, here you will be having broadly classifying it as enhancement mode and depletion mode MOSFET. So what is enhancement and depletion mode MOSFET? So here this gives the structure, symbolic representation of a MOSFET where we will be having three terminal gate, drain and source. So the voltage between the measure between the gate and source is called as VGS, and the voltage between drain and source is called as the VDS. Now coming to the N channel enhancement MOSFET. So what is an enhancement MOSFET is the semiconductor substrate is not inverted directly under the oxide with a zero gate voltage. That is, this N plus and N plus region are isolated for the zero gate voltage. So the positive gate voltage will induce an inversion layer, then it will connect the n-type source and the n-type drain region, and it results in the formation of the channel. The source terminal is the source of carriers that flow through the channel to the drain terminal. Electron flow from the source to the drain, so the conventional current will enter the drain and leave the source. So here the direction here in the symbol, it indicates the direction of the conventional flow. So it means that the conventional current is entering the device. The resistance of the channel depends on the number of free electrons in the channel, and the number of free electrons in the channel again depends on the gate potential of the device. So the gate will be controlling the channel length as well as the amount of current flowing through the device, or I can say that the resistance of the device will be decided by the gate potential. As the concentration of the free electrons forms the channel and the current through the channel get enhanced due to the increase in the gate voltage, we have it as N-channel enhancement MOSFET. So as we discussed here, we will be having a gate voltage which will control the channel width and the drain voltage which will be which will act as an supply for the current flowing through the device. So now coming to the N channel depletion mode MOSFET. Here, the N-channel region exists under the oxide with zero voltage applied to the gate. The threshold voltage of the MOS device with a P-type substrate may be negative. This means that the electron inversion layer already exists with a zero gate voltage. The N-channel shown in the figure can be an electron inversion layer or an intentionally doped N region. We can control the drain flow by varying the depletion of charge carriers in the N-channel, and hence we call it as a depletion MOSFET. So in depletion MOSFET, we will be having an inbuilt channel at zero gate voltage, whereas in enhancement, there will not be channel. The channel will not exist for the zero gate voltage. So that is the difference between enhancement and depletion mode MOSFET. And this gives the P channel, the symbol of the P channel enhancement and the depletion mode MOSFET. So here we can see that at zero gate voltage, there will be no channel in case of the enhancement, whereas in the depletion we will be having a predefined or pre the inversion layer will pre-exist at zero gate voltage, and the symbol is the given here, and we can see that the arrow mark indicates outside. It means that the conventional current will be flowing out to the device, that is the current will be due to the holes which is from the source to drain, and hence the conventional current will be going out from the drain terminal towards the it will flow outside the drain terminal. So here, this MOSFET can operate in three regions. That is, the first one is the cutoff mode. So cutoff mode is nothing but when I apply for an N channel, when my source voltage is going to be zero, when VSB is equal to zero, and I apply a gate voltage such that it is less than the threshold voltage. So there is no channel formed, and hence there is no current flow. So the transistor is said to be in the cutoff state. Now, when I increase my VGS such that it is greater than the threshold voltage, so threshold voltage is a point at which an inversion layer will be formed and a channel is formed due to the inversion layer. So now if I increase my drain voltage, that is drain to source voltage, then a current proportion to VDS flows from the source to the drain. That is, there will be movement of charge carriers from the source to the drain, and now the device will be acting like an voltage controlled resistance. That is, it will be acting in the linear region, and the current flowing through the device will be proportional to the applied drain voltage. Now, the third case is pinch off point, that is the edge of the point at which the channel reaches the drain, that is the channel touches the drain. If I increase the voltage, that is when VGS is greater than VT, at one particular point there will be the channel will not that is it just touches the drain, and the channel is reduced to zero inversion charge at the drain. So the drifting of electron through the depletion region between the channel and the drain has begun now. So this point is called as the pinch off point. So the next one is still if I increase the channel, or if I increase the voltage, the channel ends before reaching the drain, and hence the electron drift usually reaching the drift velocity limit across the depletion region to the drain. The drift due to the electric field produced by the potential between the drain and the end of the channel will be such that the current remains constant. The saturation current will be remaining constant. So this is the point where VDS is greater than VGS minus VT. So after that, if I try to increase the transistor will go to the breakdown region, which will cause an irreversible destroying of the device. So here in this video we have discussed about what is meant by a MOSFET and what how it operates at various voltage of gate. Thank you.